Hey guys, we are going to wrap up our Cocos2d-x game. So we left, let's see here. So what did we leave it with? We left the game. Not sure what's happening there. Let's run it. Just to see where we left off here. Okay. So we've got our player movement done. We've got our bad guys somewhat done. The ones that are the same color as us don't attack. The ones that aren't our color do attack. And really the attack is pretty trivial. It's a Cocos2d-x action, right? Cocos2d-x has these ideas and concepts of actions. And the actions, you can just run these actions. So it's almost like scripting some sort of behavior out of the game. So for example, we could simply script the bad guy to, over the course of 4 seconds, move to the location of where the player is. And that's exactly what that red cell is doing. He's trying to attack me by, as soon as he appears, he's going to trigger the action of, over the course of 4 seconds, he's going to move at my position. So you can quickly dodge. Not a big deal. I built this game a long time ago, and the version that I built had a lot more to it than this, but this gives us an idea of the game. You can see, even though I'm eating the cells that are of the same color as me, not sure why it won't reload the scene, but that's fine. Okay, so you can eat the cells that are the same color, but you'll notice the overlay. You can see this fluorescent green starting to appear. That does damage to us even though we're attacking the cells of the same color, which means we would get a point instead of deducting a hit point. So instead of taking damage there, I should have actually scored a point. So we'll add that logic today. At the end of yesterday, we also want to remove these final frames of the explosion. So for example, when you actually hit a cell, whether good or bad, it will explode. It'll either do damage to you if it's a different color, or it'll give you a point if it's the same color. But regardless, we trigger that explosion animation, and that final frame of the animation remains. So we've got to fix that. We've got to fix the logic that we get a point when we eat our own color. And also we want to put a couple of labels onto the top of the game screen so we can see our score growing or our hit points dropping as we take damage. We also want to today move this overlay so it's right in the center of the game screen. Right now this overlay is off to the bottom corner. So we'll fix the location of that. Yeah, so let's get started with that. So I guess first we can go ahead and deal with the bad guy, such as removing that final explosion frame when he gets removed from the game. So let's fix that where it shows the explosion. Let's do that first. So what's going on is this destroy me is getting called. If I put a breakpoint on here, and you can see a cell just bumped into me. As soon as a cell bumps into me, he gets blown up and the explosion triggers. Then after the explosion animation triggers, right here, let's go through this. So we can actually go up. We can go up. Actually, we can't go up the call stack because this destroy me was called by a function pointer callback to this function. We'll continue and then we'll keep playing the game. As soon as I blow up a bad guy, good. So if we go through the call stack, we can see what's going on. Right from here, the update function. Remember, this gets called on every frame of the game. Remember, the game layer is the source code file that creates the scene to display the game that we're seeing, right? So it contains the background and that overlay and the player sprite and the bad guy sprite. So it contains everything. And in this update function that we call actually 1/60th of a second, because we set our frame rate is 60 frames per second, we call a method called handle collision. So as soon as we collide with any one of the bad guys that are currently displayed on the screen, that bad guy is removed. Okay, so let's look through this code. So we check to see if the pool, and the pool is just a vector, which is a container class in C++. It's just like an array. If you're familiar with programming, an array allows you to store multiple of something. Our pool allows us to store multiple of the bad guy classes, okay, these baddie classes. So what we do is we handle the collision on every frame update. And what we do is we loop through all the bad guys that are in that container. So we loop through them and we do this if statement. And this if statement is really a function call that returns a true or a false back. And all it's saying is get me the position of where the bad guy is on the screen. Get me his radius so we know how big, because the position is just a point, right? It's an X and a Y coordinate, but it doesn't represent size. So the radius will represent the size of the bad guy. So since the bad guys are simply cells, they're pretty much circles, a radius works fine for defining his size in the game. So we can do our physics, we can do our collision here. So we say the bad guy's position plus his radius to give him some dimension or size. And then we check that against the player's position and his size to see if they're touching. Right? We won't go through the collide function, but you can download the source code on GitHub and you can see the geometry that we're doing. Just hold on 1 sec. I just want to actually update my stream. So we're actually on day 5. So creating a game from scratch using Cocos2d-x, day 5. And final day. Just updating my stream here, guys, so bear with me. Cool. Okay, sorry. So the is collide simply returns a true or a false if the bad guy touches the player. And we, like I said, we're looping through every single bad guy on the screen to test if there's a collision. If there is a collision, we jump into here. And most importantly, we jump into the bad guys remove bad guy function. So let's jump into the call stack, and we can see the breakpoint here is triggered. So we're inside the remove bad guy. Unfortunately, we can't see the game because it's out of focus and we're debugging, but we know that the player collided with a bad guy cell. Okay, so now what does remove baddie do? So the function will create an animation, like a Cocos2d-x animation that we gave the name explosion. So inside the animation cache, there's a key, and this key is the string explosion. So we can fetch that animation, which is simply just multiple sprites that get played together, right? So an animation with sprites is just like, you know, you ever take like a textbook or your workbook at school, and you'll draw little frames on the corner of the pages, and as you flip those pages, you can see like the guy walking slowly, and it's basically each page is a frame. That's all an animation is. It's just a bunch of sprites that get played sequentially one after another, and they represent movement, right? So this animation is representing the explosion. So you see the explosion go from small to a bit of a mushroom cloud, and then it shrinks again. Okay, so we get the explosion animation. We create an animate around it. So the animation is just an animation. The animate takes an animation and creates an action out of it. So it's important that we put the animation with inside of an animate in Cocos2d-x so that it can be put inside a sequence. A sequence accepts actions. So what are actions? Well, in our game, actions are the movement, right? Let's run this. I know we said we're going to destroy that animation, but let's run this. So I'll show you an action as soon as it occurs. Right there. That cell moving towards me. We had some logic. As soon as we add a bad guy onto the screen, which is every 5 seconds, if he's a different color than the player, we create an action called the move to action, which will move to the coordinate or the point where the player is, and we define a speed. So that's an action. So in Cocos2d, 2d-x as well, there's just a ton of actions that you can apply. And if you're thinking Cocos2d-x or 2D is kind of a pain in the ass as for being a framework to build your games, well, it actually isn't. If we go ahead and look at Cocos2d, let's just Google Cocos2d for a second before we get into code. So I'm having rendering issues clearly, but you can see that, what is this game again? Kingdom Rush. I love this game. Kingdom Rush was built with Cocos2d. A lot of these other games here as well are built with Cocos2d. Here's some of the featured games. Big Fish Games. Big Fish Games. I've heard of them. What do they do again? They've got, yeah, so they created Dungeon Boss, Gummy Drop, Fairway Solitaire, Big Fish Casino. They build their games on top of Cocos2d or 2d-x. It's kind of irrelevant. There's Cocos2d contains this family of different language-based versions of the framework. So Cocos2d-x is C++. Cocos2d-js is JavaScript and HTML5. XNA is Microsoft's old XNA Studio. It's I don't think this project's been updated for a while, but it still exists. And if you ever program in XNA, you can use the framework of Cocos2d on it. If you program in Swift and want to build games, you can use their framework. And if you're a Python programmer, you can do it with Python. So it's a very strong framework. I mean, it renders 3D, it renders 2D. We're going to add sounds today. So we're going to add sound effects today. We're going to add background music today. It does animations, it does actions. So actions could be things like, like if the game is over, you could display, some text on the game screen saying game over, but the action could have it rotate 360 degrees and at the same time maybe shrink. So it looks like, there's some sort of movement in the game over. It's like circling and shrinking at the same time. You kind of see that at the end of games sometime when you lose a level or something. Anyway, it's really quite powerful if you get into it. Some people on the chat have said, why aren't you using Unity 3D? Well, it's really powerful, but if you're more of a hardcore developer, you tend to kind of go more with code-based frameworks than these game engines, like Unreal Engine. I shouldn't say that because Unreal is driven by C++ underneath, but a lot of the animation is kind of drag and drop in a way. But I mean, like Unity builds amazing games too. So Cocos2d, 2d-x is meant for more of these Zynga type of games like Farmville, more of these 2D isometric games, whereas Unity is more for three-dimensional games. So anyway, you just have to know the tool that you want to use. If you're building more of an iPhone, Android App Store game, then Cocos2d or 2d-x is what you should really be looking at. Okay, enough of the sales pitch. So let's go ahead, and we want to fix the fact that we still maintain the final sprite of the explosion animation when the bad guy dies. So what I was missing here is this destroy me function. So we're stopping all the actions from the bad guy on the screen. So what this line is doing is if he's still moving or if he has an explosion animation going on, those are all actions. And it's going to stop and then remove them all from itself, from the bad guy sprite that was on the screen. The reason why we do this is because we release the memory that's used for all of that. So it's important to do that. But one thing I should have added would have fixed the explosion. I'll do that right now and we'll see the explosion go away. Is we need to do this. If this, and all that this keyword is it's an instance of a bad guy. So the bad guy that's about to be removed off the screen. So if this get parent, and this will check if this bad guy has been added as a child to a parent object. And if we go back to game layer, when we add a bad guy to the screen, right here, when we add a bad guy to the screen, there's a bit of logic going on. We don't care about that. But eventually we add him to the game layer. So we're inside the game layer class right now. We're adding to the game layer class the bad guy as a child. So when we remove the bad guy, we want to actually get the bad guy's parent, which will be that game layer we added to. We added the bad guy to. And we want to remove him from his parent. So let's go ahead and we go ahead and get the parent again because I needed a reference to him. And from parent, we are going to use the function remove child. And it removes the child based on the this keyword. So I'm passing in the actual bad guy instance. And it will just look to see inside of his collection of children. Is this within the collection of children for the parent? If so, remove him. So if we run the game now, that line of code should have done it for us. That should remove the final sprite that's stuck on the screen. Takes a little bit of time to compile. I changed a little bit of code. C++, I know my machine isn't the fastest because I kind of have it all extended out. I'm running boot camp. It's an iMac running Windows, but I boot camp in. It doesn't really matter. Anyway, okay. So if I eat one of these bad guys, the explosion's now gone because we removed him from being a child of the whole game layer. So now he's completely removed from memory. He's gone. He's disposed of. And any sprites that were left will be removed. So good. So we fixed that. But we talked about making this blood splatter overlay right in the center. So let's go ahead and do that. So we'll fix that as well. Okay, so that is in the game layer init method, if I recall. So game layer init, yeah, here we go. So right here is where we add the blood overlay. And it's not really blood, it's like fluorescent green, gross goo, right? So we create a sprite object in Cocos, fine, using the image overlay, which is in our resource, right? Inside of our resources. The resources aren't brought into the project, but they're in the folder structure. Anyway, so we load up the sprite from that PNG, great. We set him to fully transparent, so it doesn't show by default. It only shows as we take damage, and we did that yesterday. Now, we set its anchor point to be right in the middle. So what Cocos2d does is the anchor point for an image by default is the very bottom left-hand corner of the image. So by this line of code where I said set the anchor point to 0.5, 0.5, means set the anchor point halfway on the X and halfway on the Y position, which means right in the very middle. So that's good. So we've got the anchor point in the middle. So when we add him to the game layer, which is what's occurring on this add child function call, it adds it to the game layer. But the problem is we need to do a little bit more to that. So we also need to set its position to be right in the middle of the game screen. And we created a vector2, which is simply a point, right? An X and a Y. We said we want its X to be the exact halfway point of the game screen. Win size contains the size of our running game screen. And then the height right in the middle, because we're dividing it by 2. So we want to actually put the game right in the middle. So set position. And we've already defined this vector2 as being the halfway of the width and height. So we can just say set position to that point. And we should also probably copy this line of code. And we'll do it to the game background too. So it's right in the very middle. It's not so obvious with the game background because it's such a large image and it repeats itself. It's just a bunch of little cells that you can't really tell if it's centered or not. But the overlay, the splatters are fixed kind of in the middle. So we want it to look like this on our game screen instead of having it kind of in the bottom left-hand corner as it was before. Okay, so the blood overlay, the game background, that should fix that problem. So let's run the game, see if that fixed it. We'll take some damage. Cool. So let's take some damage and see the overlay. Make sure it's showing up right in the middle. And it looks like it is. We can see the overlay now is splattered, focused more on the middle. So it is centered right in the exact middle of the game screen. So we had to set our anchor point halfway and halfway, right? The 0.5 and the 0.5. And then also we had to set the position for that sprite to be the middle of the game screen. So you can just see the overlay getting brighter as we take more damage. And eventually once we hit 10, or once we've taken 10 hits, we go back to the game menu. Awesome. Okay, so we need to add sound effects and music, so we'll do that. And we also need to add text onto the game screen. So let's go ahead and do the game screen. So forget the music. Game state, we don't care about that. So let's add some labels. Do I still have Windows size? Perfect. Okay. So we're going to put some labels kind of right at the very top of the game window, and kind of one label on the left-hand side to show health and one label on the opposite side to show your score. Okay. So let's create a string to store what we want to say inside the label. So string, we'll just call it health, is equal to health, and we'll just add to it std toString. So there's a free function called toString that's built in, and it will convert any numeric into a string. So we want to go core. We want to go core shared instance. Remember, our core object is a singleton that stores all of our running game information, such as like the current hit points of the player. So get hit points. Sweet. So now this label, we're in our init, and we default, we start off the game with 10 hit points. So this should read health 10. Now let's put it to a label. So we need to define a private variable inside of our header for game layer. And we need to define it as a private variable in here because we need to use it throughout the other methods inside of game layer. So we'll go ahead and it's label. So here we go, label, that's Cocos2d label, and we'll call it underscore LBL health, sounds good. And let's create it on the stack. So we'll actually initialize this. So we'll go label create. And remember, everything is create. It always, Cocos2d always uses create, like almost all the time. Whenever you create Cocos actions, labels, menu items, buttons, scenes, layers, sprites, you'll see create a lot. Now this one has some derivatives of create though, and I think we're going to want create with true type font, TTF. The reason for that is, let's just go ahead. Let's just go to our repository, samples. This is where our code is. Now we've got a folder under all of the resource files for our game, and we got a couple true type fonts that are packaged with the game. So we can use this Camry font, sounds good, to use for our label. So let's go ahead and create TTF. Okay, so first off, we need to pass it a string, which is our string above. Maybe I won't create it here. I'm just thinking, we don't want to create it here. Let's have it uninitialized. That's fine. I think let's just create it in here. It makes more sense because it's not being used yet anyway. And I have the string defined right here. So why would I create it in the header when I need to pass it a string to display? So we'll go label, TTF, create, and we want to pass in our string, then a string to our font location, and then the size of the font. So we'll say the string we want to pass in is health, and we'll hard code in a location to fonts. I just want to make sure it's fonts. I'm just actually going to copy this font name. So fonts / so we drill down into that directory and the font name. So when we started our app delegate, we already told it that our default resource directory is resources. So we're saying that our default resource path, like where all our images are, where all our sound effects are, all our fonts are in the folder up, like one folder up from where our running executable is, and resources. So if we go back to here, that makes sense because our build output is, I believe, in here, maybe in here. Right. So we're running, it's actually, I might have to change that. It probably shouldn't be resources. It should be default. It's probably going up. I'll have to look into it, but it is resolving the location. Anyway, so we've already defined our default resource path, so it's quick and easy for this function call to then go and work from that default path and work down. So from underneath resources, it goes to fonts and finds this font. And then we define a font size. So we'll say it's 16 points in size. It's just like if you were using Word, like a word processor, you'd say, you know, you can type in a font, your text, and you can say its font size is, you know, 16 points. Okay. So label health, no operator. I better new him, and I better, what am I doing here? Label. I don't think I need to do that. I think I'm just returning back the wrong object. I think I'm just returning back, and I think I just need to return back a pointer too. So all it is this is returning, this create method returns a pointer to the memory location of the label. So all I am missing is adding our trusty pointer. So it's not a label, it's a pointer to the memory location of the label. Good, so that fixed it. And it's going to display this text onto the screen. Seems like I'm getting something here. Label TTF. What am I? Maybe I'm getting a weird issue. What am I doing here? So let's see. What? Create with TTF. Oh, I think I didn't mean create. I wanted create. Oh, you know what I'm going to do? I'm going to use not label TTF. I'm going to use label, and I wanted to use that create with TTF. And that way it returns back perfect. Yeah, so the way I had it was it was returning back a label TTF object, not a label object. I don't know the difference. I probably could have left it as label TTF and create and just changed this label type to label TTF. Don't worry about it. Cocos has some technical debt in the project. They've been refactoring a lot of these classes and combining them with other ones. So yeah, nothing to worry about. Not that I can see. So let's go ahead, and we need to give the color to the text. So let's give some color to this label. So it isn't just the default color of white or black, whatever it might be. We want to set its color. And it takes in a color 3B object, which is part of Cocos. So we can say color 3B, colon, to get the static member of it, to get a static out. And we want to say, let's make it red. So there's a static function inside of here, or a static variable that's a constant. That's just an RGB red. So that's fine. This will set the color now to red for that label. And then obviously we have to set a position, right? So we want to make sure this label shows in the top left-hand corner of the game screen. So we'll go label health, and we'll set its position. And now let's create a point. I'm going to make a bit of white space there. So a point in Cocos is vec2, a vector with two points to it, an X and a Y. So, excuse me. So the first argument in vec2 is our X location. So what we want to do is we want this label to be offset from the middle of the game screen. So what does that mean? The X location will be, we want to get the middle of the game window, and we defined a variable already called win size that has the size of the game screen. So we want to get the win size. I'm going to put some white space here so what I'm typing is a little more readable. We want to get its width, and we want to divide it by 2. So what this is giving us is the exact midpoint of the game screen, but with the width. It has nothing to do with the height yet. It's the middle on the x-axis of the game screen. And then we want to minus 50 pixels, let's say. We'll use that. That's probably a good amount. So we're saying get us the width in the middle, the half width, which is the very middle, and then let's move 50 pixels to the left. So this label now will be just offset on the left-hand side of the middle part of the screen. So that's our X. Now let's define our Y axis of this point. So it'll be Windows height. So win size dot height. And this height will actually return back, let's say 320, whatever the height is of our game screen. So we want to have it, the label, right near the very top. So what we're going to do is we'll say height minus, let's say 20. So it'll be almost at the very top, except down about 20 pixels. So that sounds pretty good to me. I think that label will display quite nicely. And it'll allow us to put a second label to show our score offset a little bit to the right of middle, okay, instead of to the left of middle. So what do we need to do now? We need to add this as a child. So one thing to remember in Cocos2d-x is you always start with a scene, then you can push things onto that scene. In this case, the game layer is a Cocos2d layer object, and then we can push on that layer sprites. We're pushing a label on using add child. So anything that derives from the base class node in Cocos2d can be put onto a parent as its child using the add child function call of the parent. So the this keyword references the game layer, and we're adding child. Maybe I just need to push the child. So label health, and let's put our Z order. So we want to say, yeah, let's say 10,000. And the reason why I want 10,000 is because I know the overlay is 1,000. So we want this label to be added higher in the viewing screen than that blood overlay. That way the blood overlay doesn't obscure our health label, our text. So that should work. Okay, I think that's good. Let's go ahead and create our second label for our score. So I'll go ahead and copy this line, and we'll just call it LBL score. And it'll be quick to do because we just did it. So std string score is equal to score plus std to string core shared core. It's our singleton call to our running game data, and get score. Maybe it was player score. Maybe we didn't add score yet. So we'll just call it get score, and this will have a red squiggly because it doesn't exist yet. We're going to add this next. LBL score is equal to exactly the same code we just did. So again, create with TTF, and we'll say score, comma, and I'll just copy this stuff because it's going to be exactly the same. And LBL score set color. I'm just going to cheat and copy this, paste that. And the only difference is, let's say this label's not going to be red. It'll be, let's say, yellow. Sounds good. You can play around with different colors, of course. And then we want the position of the score label to be the right of middle. So instead of pushing it to the left with the -50, we'll push it to the right with a +50. And we'll leave the height the same so that the labels are aligned vertically, but they're kind of offset horizontally, using kind of the origin as the middle of the screen. And you'll see, as soon as we run this, you'll see exactly what I mean. All we need to do is jump into core and add a get score. So let's go ahead and fix that so we can run and see our labels. So player hit points, unsigned short because a score can never be negative. Player score is equal to, we default, the player always starts out with a score of 0 because he hasn't done anything yet. Remember, U is just that suffix for defining the type. U means unsigned int. You don't have to have it there, but the compiler will give you a warning. Okay, let's add a public method that returns unsigned short get score, and we need to increment score. So we can create a method that returns nothing, and we'll just call it I don't know, like what should we call it for player score? I guess it doesn't really matter. It's just, it would just be like player scored. How's that? Player scored. Nothing's passed, nothing's returned. And this function is simply going to increment that private variable by 1. So I'll create inside the header file. And since it's really easy to type this, we'll just go this player score plus plus to increment by 1. So that worked. Now let's define our get score, and all it's going to return is, you don't need to prefix with the this keyword. All this means it's the instance of the running class, which in this case we're inside of the core class. But I do it just for just to be explicit, especially for people kind of learning or watching this. And I know that this might be fast for some, it might be slow for some. Some of you are probably just laying back and just taking it in, and that's kind of all I would expect. I mean, watching this might help you learn C++ to some extent, and it probably does, but I think my training courses that I do on other alternating days would help you with coding more than this would. This just gives you a taste for building a game. And I know the game it's kind of weak, but the actual real game that I built off this is actually not too bad. It's got power-ups and leveling and infinite levels and scores and different screens and options and all the different sound effects. But, you know, I don't want to have this go for another week to add all that. Okay. All right, so we fixed core. Everything should be good. If we go back to our game layer, get score is now resolved. We don't see a red squiggly, so there's no error. And we should be able to run this and see those labels display. And it should show 10 for the hit points and 0 for the score. Oh, I may not have referenced the string source code. I might have an error. We'll see. We shall see. Nope, we're good. So you can see the labels now. So you can see exactly what I meant. The labels are at the same height. They're 20 pixels down from the top, right? We define that right here. That's the Y coordinate. And the X coordinate is, the middle is right in between them. And remember, the health we offset to the left by 50 pixels. And the score we offset to the right by 50. So awesome. Now if I hit him, we're not adjusting our, well, we are. The health is actually going down, but we're just not updating the health. So we need to update these labels because I know for a fact our health is going down. Otherwise we wouldn't see the blood splatters. Okay. And right now I have to add some conditional logic to up our score. So let's make sure we update these labels as we take damage or gain points. And also let's start handling the condition of if I eat somebody of the same color, I get score instead of take damage. Okay, so how do we do that? How do we update our UI? Let's go into our game layer header file and define a function called, it doesn't need to be public because it's only going to be called internally, but I don't care. It's underneath the public functions. So it's exposed to anybody who can reference the header file. It doesn't matter. I'm going to call it update UI. And we'll pass in float even though I probably don't need it. And all float is, it's the time between the last frame. We learned about that on previous days. So up, my typing is ridiculous today. I keep complaining. If you've been here on my previous podcast or streams, I complain because I got a big microphone on my face and I can't see my keyboard. Anyway, I won't complain. So delta time, let's actually go to, I'm going to control save, control S. Let's jump to our actual implementation, our C++ file. And we can, I'm going to move this update UI function though. I don't like where it is. I want it to be closer to our update method. Okay. So all I'm going to do now is within our update method, let's just go back in time to yesterday and on previous days. Update method inside of game layer is a overridden function that's part of the Cocos2d-x base class node. So I'll show you what I mean. If we go into our header file, our update function has a keyword in front of it called virtual. When you see the virtual keyword in front of a redefinition or of a definition of a function, just like here, it means we're overriding the base implementation. And what does that mean? It means the base implementation is within the base class. So let's walk through this. So game layer is a class. Just read it phonetically. Class game layer. So it's a class we created during this stream. It's our class. But this colon and a definition of, not a definition, but an inclusion of another class means our class inherits or extends all the functionality of the class after this colon. So we're bringing in a class called layer, which is part of Cocos2d. So all the functionality in layer is given to our class game layer. So to use that functionality, for example, we need to override that base class's functionality. So for example, I may be able to F12, I can't F12. If we F12 into layer and we look to see if there's an update. Let's find update. Update display. Create draw. So we've got draw. We're probably getting pretty close. It may be in a further base class. Update. So let's drill down. The update function is not in layer, but it may be. So layer is part of the Cocos2d framework. It's a class they created. So we're looking at their source code. And it also extends or implements the functionality from a class below it called node. And let's just look to see if node has control F. Update. Schedule update. We're getting close. Here we go. So right here is the definition of a function called update, and it has the keyword virtual in front of it. So what does the update method do? Well, let's read the comments by the developers of this framework. The update method will be called automatically every frame if schedule update is called and the node is live. So how is a node live? Well, the node has to get that create method called against him. So for example, this update method will be called on every frame because we did the init, and init method got called on this game layer. And I know I'm jumping around a bit, and we won't go too far. But on this on new game callback right here we create, this is our game layer class that we were just in. The create method is called against him, and he's added to a scene, which means he's going to be in a scene that is actually pushed onto the director and becomes the foreground running game scene. So this create functionality was nothing we added to our game layer class. You can see there's not a method called create, but it sort of is getting created by this macro. This is just the scaffolding that you're supposed to do in Cocos2d. And if you look at any samples, you'll always just see this similar create func passing in the class name. And that's it. That'll automatically make it kind of a live object for you to create a scene from, push it onto the director so it's running in the foreground as, you know, something that you can see and play a game on. So anyway, this virtual update method will get called every frame by the underlying base class. It does all the magic of knowing what frame, when to call this update method. But just know it basically gets called once every 1/60th of a second because our frame rate is 60 frames a second. So this update method gets called very quickly and all the time. So from in here, we want to call update UI and pass in the delta time, which is the elapsed time that has expired from the previous frame. We don't need the delta time in this case. So inside this update UI now, we can do a bunch of logic to update our labels. This is just here to update our labels. So I'll redefine those strings. Health, plus std to string. So we're just forcing a unsigned short to become a string. So we don't have a core object, so I'll go core. I'll just call this static function to get us the instance and to get player score. Or we just called it get score. Or sorry, it was get health. Get player hit points. What was it called? Get hit points. There we go. So this will return the current game hit points. And LBL health. And we need to set its text. Bear with me. I don't remember the name of the function. Set string. Perfect. And it should just simply take a string. So we'll pass it that string. So now the label will be updated on every frame based on the hit points as they get adjusted in the game, as we take damage. And that's all we need to do. I'm going to create a second string for our score. And we'll call it score. Same idea, really quick and easy. And this guy's storing our get score. There we go. And we have to update the string on label score. So we go set string. Cool. And we just pass in score. So now on every single frame, the value in the labels will get updated in real time. So the score right now isn't working. It'll just stay at 0, but the hit points we should now see get reduced. So let's run our game and check that out. Dun, 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 dun. Cool. Awesome. We can see our frame rate in the bottom left-hand corner, 60 frames a second. That's how many times that update gets called, and we rewrite the label text. So as soon as I hit somebody, my health is going to drop. So we can see it drop to 9, 8, 7. So now that works. We're updating our UI, our HUD, our frame, or our labels. Cool. So we can see that is over the green blood splatter, but it is hard to see. Maybe a different color would work. Maybe having another label underneath it to provide some sort of solid background, maybe an image underneath it. Anyway, we're not gonna tweak the game to be ideal. Okay, so we know our HUD is updating. That's cool. We just have a problem. Our score is not working. So let's go and let's look at our update method that gets called on every frame. So we handle player move. We update bad guys. All update bad guys does is it simply adds a new bad guy every 5 seconds to the game screen. So I'm not too concerned about that method. But handle collision is where our game logic as far as game over conditions are checked, where our hit points are reduced, and where our score should be incremented if we do the right thing. So let's look at handle collision. So we check to see if the player hits a bad guy on every frame. If he does, we remove the bad guy. We know this. That's fine. But we want to check to see if this bad guy is the same color as us. And if he is, then instead of taking a hit, the player should gain a point. So handle if player 8 same color cell, or took damage. Not a great comment, but okay. So if we look at our baddie, which is our instance of the bad guy that's about to get destroyed and removed, the guy we hit. If baddie, I think we added a get color. Yeah, so our bad guys, we added a function called get color, which returns back the color of the bad guy cell. So if color is equal to the player's color, and I think we've got a private variable called _player that represents our player, and we call his get color. So if they're both the same color, then we gain a point. We don't lose a hit point. So we want to go to our core, and we added a function called player score or something like that. Player scored. And remember, we just added this. All I did is I incremented the private variable of the type unsigned short by 1. So it starts at 0. As soon as this gets triggered, our score becomes 1. And if I trigger it again, it's 2, and so on. Else, we know that we hit a bad guy who's a different color than us, so we have to take damage. So I can simply move what we already have, which is take damage, and put it inside of the else. So now our game mechanics are starting to make a little more sense. If the player eats cells of the same color, you gain a point. If you get hit by any other color, you lose a hit point. Awesome. So if we run this, we should see our labels responding properly. So let's give it a shot. So we start out with a score of 0, obviously. Yeah, I should gain a point because I chewed up a cell of the same color. I'm gaining a point. Now I should lose a hit point. Perfect. And the overlay is slowly starting to give us a bit of fog of war, a bit of blood splatter in our eyes to make things a little more difficult. And I scored. And I can score on this guy because we all of a sudden became the same color. If you weren't here before, remember how every 12 seconds the player changes colors, so you can then hunt different cells. Anyway, you get the idea. Our score and our health are responding appropriately. There's one thing that I notice is a problem. is we are not seeding our random number generator. I'll show you what I mean. Every time I run the game, even though it's random, like if you were here yesterday, we added the bad guys into random locations using a random number generator. Except this doesn't look too random. The blue cell always appears here, and then one always appears here. Watch if I restart the game completely from scratch, and we'll see the same behavior. It's almost like I scripted how the cells should be added. See how he's here again, and then another blue one is up here next, and then I think a red one down here, and then a green one over here, and he moves to the far left or something. So it's almost like I'm running a replay of a video of the game playing, and I'm not. I'm totally not. It's supposed to be random, but we defined inside of, we'll fix that right now. We defined some random functions inside of our core.h header file. So we need to seed our random number generator. So by seeding our random number generator, we get something called atrophy. Atrophy means randomness. So what's going on is we need to set some atrophy or randomness on the running CPU to get us a random number that is truly random, not just as soon as the game starts, it is random, but it's random in an order that, because we didn't seed the random number generator, it's not random. It is actually more, it is predictable, as we saw. So, you know, whatever. It is what it is. This is just what you do when you use the rand function. And to be honest, I should be using C++11, which uses these seed engines and these seed algorithms. But it's a little more work, but it's the proper way of doing it. But I am not doing the proper way of doing it. I'm just copying how everybody else does it. That line of code will seed the random number generator with some sort of random time value. Time is a time that is slowly changing, like ticks on a clock. Anyway, time is the time based on your internal clock of your machine, and it's how many ticks. If I recall right, I know in JavaScript, the time ticks are, it's like 1970. It's how many ticks have occurred since like January 1st or something like that, 1970. I know what I'm saying sounds ridiculous, and you can forget it now that I've said it. It's just I don't even know why. There was some sort of standardization for computer time back in the day, and because 1970 had already passed when they defined that specification, they defined it to say how many ticks have occurred since a date that was in the past. I don't know. Anyway, if that makes sense, it makes sense. If it doesn't, don't worry. Okay, so now we seeded the random number generator. So hopefully we get a little more randomness now when the cells are drawn onto the screen. And I don't need to seed this random function because it's just calling the same guy. And I probably shouldn't seed it in the function. I probably should just seed it at one time outside of the function, but let's see how this works. So now we can see the blue showed up, but not in the same position as before. And there's clearly an issue where they're all gravitating to 0.0. And I know what this bug is. You can see we've just got some logic in our code where the game first initializes. I default the player to 0.00. So these cells think the player is actually down in the left-hand bottom corner. It's kind of a goofy bug. Something froze on our game for some reason. Hopefully it's not our random number generator problem. Let's give it another shot. I don't want to see that freezing occur again. So he's the same color, so he isn't going to approach me. I could eat him though. And we got a froze. So maybe we are having some issues with this. Let me just see. Let's unseed the random. Worst case, I could just seed, put this line inside of even our main method, our entry point, so that the seeding always occurs, and it always occurs right at the very start. As long as we call the seed function before we call the random function, we should get randomness. So now we're back to where we were. It's no longer random. This is here, that's there. Red guy goes to the bottom corner, green guy then goes, and then a green guy. So reseeding clearly froze my system. Was not a good move. Maybe I'll just put it in app delegate. I know we call app delegate, and this is kind of our entry point into our code. So let's seed our randomness. And let's give this a shot. I may need to reference. I think we're okay. Let's build. So hopefully this seeding will not freeze our computer now. Cool. So far, so good. I'll take some damage. Why not? Let's eat him. Why not? Trying to get it to freeze. Clearly, the seeding, reseeding was an issue, and was a dumb move on my part. But it's fixed. So we seed once, and we can random as much as we want. Oh, good. He's green. Everything looks good. We're back to normal. Everything's working. So what do we want to do? We've got a game over condition where our health gets to 0. We go back to the game menu. Let's go ahead and add a game win condition. So we can just do that inside of game layer. We can do it where we've got the game over condition. So for example, if the hit points are less than or equal to 0, we go back to the game menu. If the hit points are less than 10, we slowly start adding some opaqueness to that blood splatter overlay. So that's the reason why the blood splatters slowly get more non-transparent, more opaque as we take more damage. That's this logic in here. And we did that yesterday. So we'll leave that, and we might as well test. We'll check our game win condition. So if core get score, and I'm going to use a magic number again, and I shouldn't, but I will. If score is greater than or equal to 10, let's assume we win, and we go back to we don't do any different. But at least we have a game win condition. Ideally, I would probably create like a Cocos2d-x action, but more specifically a sequence of actions, and then like have a label display, and then a function callback to write some stuff to the screen, and then maybe a timer, and then after 2 seconds we'd go back to the game menu. So at least we saw maybe a label appear briefly saying you win, or a label appearing briefly saying you lose. Maybe we'll add that. We'll see. So we've got our game win condition. Let's make sure that is golden. So I just want to eat guys of the same color. I don't want to lose. I want to test the game win. We've already tested the game over condition. I probably should fix that bug where they always go to 0.00 by default until I do my first move, but I don't know. We'll see. So almost 12 seconds have expired. I'm waiting to blink and change colors. Turn red. Brilliant. So we'll go eat. I'm going to take a bit of damage here because the red was on top of a green. Come on. Red again. That's buggy. Shouldn't be, we should actually only random to a different color. So I guess it's another bug to look at, but that's just how it is, right? You build games, anything, you'll have a bug now and again. No, I'm getting in a bit of trouble here. Perfect blue. Let's start eating some of these guys. And we obviously hit our game win condition. We got 10 or more points. So we've got our game win condition. I know it's not exciting. Normally you would replace the scene with maybe a win scene, or we would have a function callback that we would display a label, and maybe we'll do that. Okay, so now we want to add some music and audio. So this is really important. I mean, what game do you have without sound effects and music in the background? So the way Cocos2d works is it supplies you with a game engine called the Simple Game Engine. And there's a second audio engine, which is just called like Cocos2d-x audio engine, I think. Instead of Simple Engine, it's just audio engine. And I've never really used that one. I've never found the need to, because to be honest, you're probably using Cocos2d to make more casual games like Candy Crush games. You know, like I said, Kingdom. What was it? Kingdom Rush? What the hell? What the hell was the game? Kingdom Rush, yeah. So Kingdom Rush is built with Cocos2d-x. All of these, you know, Matching with Friends, a Zynga game. All of these games definitely use sound and like sound effects and background audio. That's cool. But, you know, it's on your tablet or it's on your phone. So you don't really need hardcore channel effects and sort of like, I don't know what the major game or audio engine does. Maybe some Doppler effects. I don't know. But these do stereo. They do multiple channels. You can have multiple effects going on. You can have a channel specific for game, for the background music. We can set the volume, all with the simple audio engine. So we're pretty much okay with just using the simple audio engine. Now, what do we want to do? So let's go and start dealing with our audio. So we want to go into App Delegate. App Delegate is the class that was created for us by our Cocos2d-x empty project. And by default, it's using the Simple Audio Engine. So brilliant. So we know we're using Simple Audio Engine. Here's the header file that's used. I'm going to actually copy that because we're going to need to reference that in a few places where we're doing our sound effects. So we got our Simple Audio Engine. Now what we want to do is, just like in earlier days, we preloaded our game sprites, right? Our images for our game. We want to do a similar thing for our audio, right? So when the game first launches, we definitely want to preload all of our audio. So where can we do that? Well, in core is probably the best place. Remember, core is our class that is always in scope. There's always an instance of it, and we get it through that shared core method. And it gets initialized right at the very start of us running this application. So this is the best place to do any initialization. So we want to create a method called, here's fine. I want to create a function called void. It returns nothing, called preload effects. We'll just call it, yeah, preload effects or sounds, doesn't matter. Preload effects. So let's add that. Cool. So it's there. I also want to create some functions called, I will create a function called void Not, well, yeah, okay. Void stop effect. So we want to be able to stop a sound effect that is currently running. We won't do it in this game, but unsigned int. And I'll show you what's going on in a second here. I guess I don't need to define the name of the function. I will let it add though for us. Squiggly, please. And we'll create the implementation. And we'll just call it effect ID. And we also want to have a couple of methods to play a sound effect and one to play music. So there's a little bit different. There's a difference between a sound effect and music in Cocos. A sound effect is something you don't loop. A sound effect is typically a small MP3 file or OGG file or even a WAV file that you play. Music, on the other hand, has its own channel, and you can also explicitly tell it to loop. So you can create kind of a loopable sound or music, so it just is constantly playing in the background. So we're going to create two methods here, one to play our sound effect and one to play our background music. So I'm going to create unsigned int is getting returned from a function called play effect, and we'll say it takes in we should create a enumeration. I don't have it yet, but we will. Sound. So that doesn't exist yet, but we'll create it shortly. Let me just see if you'll let me create him first. So let's create him. Sound. Cool. I got one more method to create, guys, and that is it returns nothing, and we'll just call set background music, and we will pass in a in this case I should say sound. I'm gonna just use a string, std. We'll pass in the string to the music file we want to play. And we should also include a second argument, which is a Boolean, a true or a false. And it's going to default to false, but I don't need to define the name of those arguments, but I do in the implementation. So bear with me. And we'll just call some music. And we'll call this loop, and we'll default it to false. Cool. So I'm going to close this. Okay, so here's our methods inside of Core to start dealing with sound effects. So this guy is going to get called when we initialize Core. You'll see that in a second. And it'll just simply preload our MP3 files for us, so that in our game, when we call to play one of those MP3 files, it's already loaded into memory. So it won't slow down our game. It'll be just instant, which is great. Because if you had a lag, if you didn't preload your sound effects, it would take a bit of time to load even, a couple 100 kilobyte MP3 file. Because the game's already running 60 frames a second, drawing, doing math, doing calculations. The last thing it needs to do is then load into memory a 300 kilobyte MP3 file and play it. So we preload it. So that's what we're going to do here. Then we got a function called stop effect. Stop effect takes an integer, which is kind of the key of a currently playing sound effect. So stop effect kind of works in conjunction with play effect. When we call play effect, we're actually going to play a sound. And that function is going to return back a unique number value, a unique integer value. We could store that integer value and then call stop effect while the sound effect is partway through. and say we no longer want to play it. So we can stop it midway. We're not going to use this though. I'm just putting it in so that we have this. If anybody ever wants to use this code, you've got the ability to play and stop an effect. But we just play the effect and let it play out, right? I mean, a sound effect is typically what, a second long, a couple seconds long, whatever it is in length. For our game, it doesn't make sense to stop a very short running sound effect. And then finally, background music. Well, we want to loop music in the background, so we just want it to run on its own music, like its own audio channel, right? A computer typically will have, depending on the driver and the hardware and the operating system, it may have like 256 audio channels. So you could run, you know, music on one of the channels. You could have sound effects from different applications you're running on your Windows machine to play sound effects. So sometimes though, I don't know if you've ever played games in the past, but sometimes you may actually have so many sounds going on at once. You may use up all the channels and you may get some weird behavior with sound effects. Sometimes they'll kind of freeze and you'll hear the sound effects just repeat and repeat and repeat. Yeah, that's kind of a bug with the underlying audio engines, or maybe the code for the developer who built the game. But nonetheless, we've got an audio engine that's built into Cocos2d-x to hopefully handle a lot of that heavy lifting for us. We just want to tell it to play a certain MP3 file. We want it to play a certain looping MP3 file for our music channel. We want to keep it really simple. And this is how we do it. Okay. So looking at this, we need to define a type called sound. And we defined our enumeration types inside of our resources.h file. Let's go ahead and do that. Enum sound. And we'll define our different sound effects in here. So we'll have a sound effect for none. I'll just say equal to 0. I don't have to. It'll default to 0, but I like to explicitly do that. And then it sets the order, just like I did here. Red is 0, green will be 1, blue will be 2, and none will be 3. It doesn't really matter because I'm not referring to these enums as an integer type. I use the name. You'll see what I mean when we get into coding. Okay. I know I'm talking a bit fast. I'm going to slow down here. So sound. Well, we've got no sound, so we'll leave none. And we also want to have a sound of the explosion in our game. So we want to be able to run our game and define our explosions. We've got two types of explosions though. We've got explosion bad and explosion good. So why do we have two explosions? Well, remember in our game, if I eat a bad cell that's of a different color, I lose a hit point. So we want to hear a bad sound effect. If I eat the same color, I gain a score point. So I want to hear a good sound effect. So we'll have two explosion sound effects. We can add more as we go, but this will give us a start. So I'll save this, and I think we're going to have a bit of a problem. Let me build, I'll show you what I mean. So we have an error. I don't know if I can change the size of this output. Hopefully if you squint, you'll see an error saying none is redefined inside of an enumerator, like one of our enumerations. So none is redefined. If I click on none, you can see it's also highlighting the none in the second enumeration. So that used to be a problem in C++ before C++ 2011, since kind of one of the latest versions of C++, or modern C++, they call it. So enumerations back in the day in C++ were unscoped. What that means is whatever these constants are, they're just basically constants defined inside of this. Now, they were unscoped, meaning that if you had 2, 3, 1,000 of these enums defined with a unique name, That's perfectly fine. But the problem is if they have the same constant name within them, they will conflict. Very dumb. It was horrible. It actually was, I thought it was a really weird oversight on C++ language's part. Now, they added the ability to add this class keyword. I don't know why they use class. It's not really a class as far as I'm concerned. It's really just a keyword to make it scoped. And what scope means is now there'll be no conflict with none, because none here is underneath the scope of sound, whereas none here is underneath the scope of color. Therefore, they don't conflict. If it kind of makes sense. If I put another none in here, then yeah, sure. Then we get the conflict because they're the same. But that you'd expect. So anyway, I am going to add this scoping. This is a modern C++ usage for enumerations. So I add this. Now our conflict doesn't occur, but I broke our source code. Everywhere where we use color, if I didn't pre-scope it, you'll see what I mean. Scoping, just like namespacing, you'll see what I mean as soon as I build this. Oh, Control-Shift-B. So we gotta fix some breaks in our code because of this scoping stuff. I think. Perfect. I was expecting that. So we got quite a few places. I didn't mean to. Great. I did not mean to do that. I want you to dock back at the bottom. And we'll pin you. We'll unpin you. I don't want you to dock there. I want you to dock bottom over. Yeah, that's what I want. Yeah, sometimes with Visual Studio, you kind of grab things and you pull them off of their docking. Not a big deal. Okay. So we can see here we've got a bunch of locations. It's clearly an error there we'll have to look at. But these ones are a little more obvious. I've got these undeclared identifiers, none, red, blue, green, so on and so forth. So the problem is, oh my goodness. Hold on a sec. Clearly I docked incorrectly because it's thinking that these are inside of there. Shit. Okay. Hold on a sec. Darn it. I'm a meathead. There, I think I might have tabbed them okay. Oh, shoot. Oh, I did some weird Visual Studio stuff. I broke it. Okay, doesn't matter. So, okay. I need to go to the player class and fix all of these errors are occurring in player.cpp. So, player.cpp. Oh, shoot. Why are you thinking? Let me open this guy up. It was just weird with, okay, whatever. Okay, so these guys were using the previous enum type that was unscoped, right? If we go back to resources, before I added the class keyword, you didn't need to prefix the use of these constants with the scope, with the name of the enum, the enumeration. Now we do. By adding class, you're forced to add that. And that's a good thing. It's just like how Java would work, or definitely C# would use this. C# uses enumerations exactly as I'm using them now, where you have to have a scope name and then the constants within. And to reference these constants within, you have to prefix it with the scope. So we have to prefix these guys with the scope to fix them. Now they resolve. Anyway, fixing bugs. And then we'll get back onto our sound. Copy and paste all this stuff. And here, and here, and here. And everywhere else, I don't see any red squigglies. So life is good. Let's Control-Shift-B to build this. Awesome, awesome, awesome. So we get that out of the way. We got another error though inside of app delegate. I added a backtick, so I had a typo. So our build failed because of the backtick, but it is good. We're good. Let's go and do our sound effect magic. So we've declared these methods, these functions inside of core. So let's go ahead and work through this. So we are going to find our preload. Our preload effects. So we need a preload of all of our effects. We should start. Let's do this. Here's what I'll do. We should actually use our resources.h properly. We're defining these enumerations. That's great. But we should also be defining static hash include string using namespace std. I'm bringing in the string source code so I can create string types, and then I'm adding this namespace using, so I don't have to add std in front of the call to string every time. So now I can go string. We're going to create explosion bad and explosion good. So let's create a string called sound explosion good. And it's going to reference the location of our strings. Or sorry, our sounds. So in our resources folder, we've got our music. So we're going to do that next. And it's got our sound. So we want to reference sound, explosion good, and explosion bad. Okay. So sound, explosion underscore. Okay. So I want the path, explosion good dot mp3, and I'll just copy this line and we'll swap it with the bad. So I just want to have a static variable, like a static. I should actually make these constants as well. I will in a sec. And I think bad. Therefore, nobody can change these strings, and we'll reference them in our code. So we've got our, yeah, that'll do. Let's jump back to core CPP. Let's preload those two sound effects. So simple audio engine, we need to include the header file, and it's in a goofy spot. It's here. I might actually use that namespace. I'm just copying this here so I don't have to, I don't remember the full path to the header file to bring in that source code. So we'll go back to core. We'll reference this using namespace Cocos2d-x. So the simple audio engine is prefixed in this namespace Denshon. So I'm just going to use it so I don't have to type it out. So now we can just do all of the simple audio engine magic directly. So simple, control space, cool. And everything in Cocos2d uses this get instance. Well, I shouldn't say everything, but you see get instance a lot. Remember our singleton pattern? So we're getting an instance of an audio engine. There's only one instance ever in scope. So preload, it's got a preload. I think it's preload effect. Is that right? Yeah, my IntelliSense was borked. So preload effect needs a char array. This is C style code. This argument is expecting const char star. Char is perfectly valid in C++, but modern C++ shies away from using more of the C style stuff, like C style strings, which are basically arrays of characters. Instead, we actually have string types now in C++. You always did with the standard library, but now they're kind of more, that's how we should do it. So since our resource header has these string objects, these string types, and we want to preload these bad boys, but the problem is we can't pass them directly. So I'll show you what I mean. Sound underscore control space, please autocomplete. Clearly you don't want to. And I believe I'm referencing this header file. Sound good? Yeah, so we are getting an error, and the error is saying that strings don't convert to char arrays. So the cool thing about the string class is it has C underscore str function. So we can just create strings in C++, and whenever something needs a tongue twister here, we can create strings in C++. That's what we did. But if older functions need a C-style string, which is typically a char array, we can just call this method, and it'll automatically construct the char array for us. So I'm going to copy this line of code and do the same thing for bad. So that is it. That was all we needed to do to preload our sound effects. Now, I should also preload our music files, right? So let's also preload our music. So same idea, but a different function. So we've got simple audio get instance and preload. It doesn't want to autocomplete anything for me. Preload music. It's not recognizing that. No member music. I think it's maybe background music. That looks better. Cool. So same idea. We have to pass it a string, which is the full string to where that MP3 file is located on the file path. So let's go back to our resource file. We'll define another string constant. Oops. There we go. And we'll call this music underscore theme, because that'll be the theme music we play. And it's in music. It's in music theme.mp3. Brilliant. Okay, so we've got our music theme and music underscore theme. So let's go and preload that guy. So music underscore theme dot C underscore str. So it'll preload, it'll go and locate that MP3 file on the file system and load it into memory so we can play it at an instant. Cool. So we also have audio tracks for our game music, and I'm actually going to preload all 14 of these guys. So let's go ahead and loop through in our preload. I'll just do a for loop is equal to 1 unsigned. So we're going to loop starting at the value 1 all the way up to 14. And you'll see what I'm going to do. We're just simply going to construct the string based on this loop for those 14 different tracks. I++. Let me just look at the naming of them. I'm actually going to rename and drop the 0. That way it'll just be easier for me to preload these guys. I can just simply use the I iterator in the for loop and concatenate some strings together and create this file. So track, okay, great. So let's go ahead, string, I don't know if I'm using std or not, but I'll just go string, music file is equal to, and it's inside the folder music / track plus std. We want a toString our I, right? Because we're iterating. I begins at 1 and goes all the way to 14. So we're just building our track file names .mp3. So music track 1 through 14 .mp3. Yeah, I think we're good. Now we just want to preload that. So we will paste that. Get instance, preload music, music file to C string. And it'll preload all 14 of those audio tracks. Brilliant. And we can play, I'm going to randomize and play the music for us. So cool. So let's go ahead. Stop effect. This is pretty easy. One line of code. Simple audio engine is that core framework we're using for our audio. Remember our trusty get instance call. And we want to, where is my error? I am getting a weird error. I get it. It's just the IntelliSense on here comes and goes. And I've seen that. I've done, I've programmed .NET since probably 2001 when it was in beta 3, beta 2, something like that. And all the way up till 2015, actually even to 2016. And then I've been more focused on JavaScript, full stack JavaScript development. But Visual Studio has been awesome with IntelliSense. None of this goofy, like it loses its mind. But it does do it every so often when I'm using C++ in Visual Studio. I don't know why. I don't know. I love the IDE. Visual Studio is it's easily my favorite IDE. I don't really like Xcode. I think Xcode's refactoring sucks. I think its descriptive errors suck. I think how it formats the code is horrible. I just am not a fan. The project files are gross. They're full of like user specific things like your folder paths and stuff. I'm not a fan. Visual Studio is great, but this IntelliSense has just given me grief. Anyway, so I do know the method, the function that I need to call. It's called stop effect. And it takes in an unsigned integer, as you can see. I hope you can see that. So we just simply pass in what the calling code provided, and it will stop the sound effect. Now, we're not using this call anywhere. I'm just going to include it because it's just a simple one line of code. When you play an effect, you get back its unsigned integer, which is kind of a unique value for that sound as it's playing. So if you ever want to call and stop that sound effect midstream, you just call stop effect with the return value of when you called the play effect. Okay, so now let's do our functionality inside a play effect. So we know we're passing in our sound enumeration. Let's go ahead and let's just do a switch statement using the sound that's passed. So case sound scope down to, oh, my IntelliSense is still gone. If sound is explosion bad, then we're going to play simple audio. Like it does that. Whatever. Get instance. Ninja Gamer schooling me here. Create a game using Scratch, using a game framework. Also, why is the room 10 minutes followers only? I don't know. What does that mean? 10-minute followers only. What does that mean? Maybe before you can chat? I don't know. I think I tweaked some of the chat stuff. I tweaked that. You know what? I'll change that right now. I'll change that. Hold on. And then I'll address your concerns. I will tweak that. Hold on. So where do I set that? Bear with me. Because if you guys want to chat, I don't want you to have to like watch for 10 minutes first. I don't think that's fair. Where do I do that? Hold on. Settings maybe. Where would I put that? Twitch Prime. I don't have Twitch Prime. Where the heck did I do that? Maybe it's security and privacy. Hold on. Block GIFs, block this. Notifications. Connections. Where did I set that? I'm not blocking any of what you guys can chat about. Oh, here we go. Non-mod chat delay is set to 2 seconds. It adds a short delay before non-mods see messages. I don't know. That's not what we're looking for. Where the heck is that? Where did I put that? Where is... where is this? No filtering, no filtering. Race, religion, gender, some filtering. Auto host, team host, vodcast host. Two-factor authentication, not what I'm looking for. Yeah, not that. Where the heck do I change my chat settings? Let's have a look. I know I saw it somewhere. I know I saw this somewhere. Dashboard, video manager, channel. No, not that. Oh wait, maybe.
I always thought good fences made good neighbors. But with ants...
Holy. We're getting there. Oh, here, I think, okay. Followers only chat must have followed for 10 minutes. So I do have that selected. Okay. How about, yeah, I guess 0. Anybody can, anybody. Follower only chat. Oh, I don't even care about that. If you don't follow, you can chat. Okay, if you guys had problems chatting, then I've got everything turned off. There should be no restrictions. So if I was blocking anybody, apologies. Cool. This room is in followers only mode. This room is no longer. Okay, so it looks like the chat is cool now. Okay, so let's see. Nin Gamer LTU. Yeah, I mean, I'm not going to go deep and create like how to render sprites on the screen from scratch. I mean, yeah, sorry. Creating a game from scratch using Cocos2d-x and Visual Studio. I don't know how I couldn't be more obvious in the title. Return an unsigned int, 0, by the way. Where do I return 0u? Where do I return that? Do you mean here? Like, or sorry, on play effect, we return an unsigned int. So whatever NinGamer's talking about, 0u, the u is the suffix after your number to define the type. It's not required. If you don't put it there, then there's what's called an implicit cast in C++, where it knows the type you're returning. So in this case, we're returning an unsigned int. And let's say I do this. Oh, I think I know what he was talking about. The Visual Studio added this return statement for me. I created the declaration and it had a return 0 there, even though it was an unsigned int. So he's right in saying it should be u. But that wasn't me who added that. That was the Visual Studio when they automatically created this skeleton function for me. So you can blame Microsoft on that one. All I'm going to be returning is what Simple Audio Engine returns when we play an effect. And I'm assuming they are going to return an unsigned int. And hovering over this, yes, that's the case. So, yeah. Anyway, okay, so sound, and then we handle explosion good. Okay, and we're going to return something, and then we're going to handle case sound none. And here's where we can use your return statement there, Ninja. Return 0u. Maybe a -1, well, but that's not unsigned. So I'm assuming 0 is invalid. I'm not sure. I assume that play effect always returns a non-zero value when a sound effect played successfully. But it doesn't really matter. Our code is never going to call sound none, but we definitely want to guard for that. Since we cover all enumerated constants inside of sound, we're handling the switch statement for the none, the bad, and the good. This is done. Obviously, there's an error here because we're not returning something. But we could also cascade our switch default. So none and anything other than none or something that wasn't handled will just return 0u. But this is going to play effect. And we will get sound underscore, what did I name those guys? Explosion good and explosion bad. So these will play, this is the bad, and this is the good. So we should be playing those sounds if that's what we request. So return, yeah, looks good. Everything should be handled. So let's do finally the background music. We're passing in the string. No longer, I didn't do the sound, an enumeration for our music. I'm just passing in the string of where that MP3 file is. So we'll do it's just a simple one line of code here. Using audio in Cocos2d-x, super simple. If we weren't using a game engine, you'd have to use something called most likely OpenAL, which is like OpenGL. OpenGL is for graphics. OpenAL is an open, kind of like an open, I don't know how open it is, but it's an audio engine that works on Linux, Mac, Windows. It's cross-platform. So actually, Simple Audio Engine just wraps OpenGL stuff. If we look inside of Cocos2d library, we should see some sort of references to, let's just see. I don't really care about this. Let's see. I don't know if they prefix OpenAL stuff. Here we go. OALD. I don't know if that's OpenAL or not. Let's just look here. Let's look at Denshawn. That's where the audio engine is. simple audio engine, references some export.h. Export.h references some base config, not too sure what else. But I'm pretty sure, I'm not too confident on the internal source code of this simple audio engine, but I'm pretty sure it just wraps a lot of the hard functionality of using OpenAL. I might be wrong, but I might be right. So MCI player, not too sure what MCI player is. I mean, that's the whole thing with these game frameworks. You know, if you created literally a game from scratch and you didn't use Cocos2d-x, you would be responsible for like getting Windows handles to to sound files. Like you'd have all these handles. You'd be doing all this really low level stuff that, trust me, by the time you're done creating like literally from scratch the ability to render sprites and move sprites and animate and create collision and do actions and play sound effects and play music. If you did all of that from scratch, I mean, you would be doing C code to call really low level stuff. You'd be doing C++ to do low level stuff. Yeah, no thanks. I don't know how many game studios don't use some sort of framework. They just don't. Yeah. Just doesn't happen. I mean, how many games have you played? Like, you ever play BioShock? I like BioShock. I'm a fan of BioShock. And on the earlier BioShocks, I think like BioShock 1 and BioShock 2, if you run them, you'll see the loading screen. It'll show Unreal Engine, and it'll show like an animation, like in the credits when you start the game. It's because it's built using Unreal Engine. Yeah, I mean, there you go. So, you know, and I'm sure you played games where you see Unity 3D splashed on the front somewhere. So, yeah, anyway. This is, yeah, whatever. Okay, so let's get our music playing. So get instance. And we want to play background music. So a little bit different than play effect. It's on a different channel and it supports a higher priority, I'm assuming. And it supports looping. Okay, and we need to take the string that's passed and we need to use our trusty function called convert to a C style string. And then loop. It takes a true or false to see if you're going to loop that music. So when the music track is done, it just continues. So this should simply play our music. This needs the C style string. So C_str and .C_str. So a little bit of gross C stuff that we were doing, but it was easy enough. Function call. Okay, so now we've got all of our hooks for our sound effects. Now we just need to get it going. So where's a good place to start sound effects? Well, let's maybe start in the game menu. So when we actually run the game menu is the first scene to open up. Let me get out of this framework stuff. Game menu. Let's include the simple audio engine. I think it's like audio / include simple audio engine. And we can do a using namespace. What was it called? Cocos2d-x. Perfect. So then I don't have to prefix all of the classes under here with this. Okay. So menu create, add the menu. Let's, before we return out of our init method, we want to start some background music. So we'll play the theme. So let's go ahead, get our, we created the method inside of core. What did we call it? Play music. What the heck did I call it? set background music, and it takes a string, which is the path to our theme. And we define that as a constant inside of resources.h. It's a static string, so I can just call it directly, assuming we're referencing that header file in either game menu.cpp or game menu h file, or in one of the h files that game menu is referencing. If that makes sense. Cool. So let's go ahead. I think that shows. Cool. And we just pass it as a standard string. And we want to loop it. We'll override the default of false to say true. So when we're on the background now, we can just loop our music as we play our game, or as we just watch the menu. So let's see if that's working. Okay. Do. Hopefully no errors. Let's go. So can you guys hear the audio? Let me just look on my stream. Yeah, so now you can hear the audio of our MP3 file called theme. So as soon as we click on play, we're going to turf this whole scene and push onto the director the game scene, the game layer. And the audio will die because we haven't done audio here. Oh, maybe it didn't. Actually, yeah, sorry. Well, the audio will keep playing until we either stop the music or it's set to looping false and it just ends. But what we want to do is for the game layer, let's create some different background music. Since we are loading up inside of core.cpp, preloading all of these tracks from track 1 to 14, let's just play these guys. Let's go ahead and do that. And then we can see some different music in action. So when we init inside of our game layer, let's go ahead and play some music. We'll just simply play. Maybe I'll just call. I think I'll probably just use that rand I method, and yeah. Okay, let's do that. So we're loading up our game layer. We're inside of our init. Let's stop any existing music. So we'll stop playing existing music. Okay. What about Nin Gamer LTU K back? Oh, good. What about the game we will be? So the game is. Okay, man. Yeah, auto's for lazy. Auto's actually not bad. Like if you're doing lambdas, so lambda functions where the return type can sometimes be a little bit hairy, auto's kind of cool. For example, auto is just like var in, if there's some C# guys out there listening, auto is the same as the var in C#, where it will pre-understand, the compiler will infer the type based on the code that's there. So the thing is I don't know if you've used, like, for example, in C#, there's something called link. And in link, you can do some really, really complex expressions that the return type is undefined until runtime. So you wouldn't even know what the variable type would be until runtime occurs. And without the auto keyword on those lambdas where a type is defined at runtime, or just like in C# using link and a type isn't defined until runtime, you have to have var. So it's pretty important to understand the concept of auto. It isn't just for lazy. I get it. I mean, you know, I can hover over the keyword core and auto will tell me what it's inferring. It's a core pointer. But yeah, I mean, it's up to you. It depends on your team. So I created this framework for a local government, for state level government, and it was a whole framework for their developers going forward to use. And I had a team. I was the architect, and I had a handful of developers under me. And I had this one guy who kept using var, and I freaking hated it. I hated var. I always wanted to be able to see by looking at the code instantly what that type is. So Nin Gamer, I hear what you're saying, auto for lazy. I hear what you're saying. Yeah, I hear what you're saying. I'm with you, buddy. I'm with you. Hey, TARDIS96, how's it going, dude? So anyway, I get it. Okay, so let's stop playing any existing music. So we want to, what should we do? So in our init, we'll just simply, instead of, we're not wrapping this method, let's just go straight to simple audio engine, get instance. And let's go ahead and stop background music. So we don't want to release the data because we want to have all of the preloaded music in memory, just in case we call that music file again. So that's going to stop the sound effect that was playing from game menu. So that's cool. But now we want to load up a random, hey TARDIS, I think programming streets should increase. I agree, dude. That's why I'm doing this. I've been on here for 2 or 3 weeks. I don't know. And I got free time during the day, so I'm streaming weekdays, but I'm also building courses for Udemy and hopefully Pluralsight. And I'm kind of using this as where I hash out my training material. I'm taking a bit of a sidetrack though. I'm doing this game, which is not going to be training for anything. It's just, we're just kind of going from scratch with a Cocos2d-x game. Smashing OpenGL and other libraries, lots of code together. Yeah. It's like smashing OpenGL and libraries with lots of code. Exactly. So, and that's what it is. But it's all abstracted from you, right? Like it's abstracted with very understandable function calls and conventions to follow. So once you kind of get in the vibe of Cocos2d-x, then, you know, you can make some pretty awesome games. So let's go ahead and loop through, and I think we'll handle adding the music inside of our game loop. So why am I doing that? Well, let's see. Let's do this. This dot update sound, or updates music. So we'll create a new function in here. So let's go to gamelayer.h and define updates music. I don't really need the delta time, but we'll accept it. So update music. I'll create the definition for update music. And we'll pass in the float delta time, which we're not going to use. Okay. So I want to now, I think maybe the best way to do this is to kind of handle it in a loop. And the reason why is I'm going to loop and check on every frame of the game to see if one of these tracks has finished playing. If so, we'll randomly play another track. So let's do that logic. First, okay, so what is this? Space Engine. What is Space Engine in? I don't know what Space Engine is. Isn't it Space Engineer? where it's kind of like a puzzle game, and the dude did it in Unity. Is that the one I'm thinking of? Space Engineer? I think it was like Engineer or something. I can't remember. Tataris. How hard is game development compared to web development? Game development, you have to have more of a physics and math background than web development. Web development, if you want to be a full stack web developer, you need to have, you need to understand back-end development, which would be like creating like web services, handling user authentication, persisting and reading from a database, a data store. And then you also need to understand some front-end web development. So obviously jQuery. You'll need to know probably some Bootstrap or a CSS framework. With game development, you don't need to know all of that. You typically don't need to know a database, but you need to know how to rotate things in 2D or 3D space, how to render things in 2 or 3D space. You got to understand game loops, like handling what to do on every iteration of a frame, like on every frame. Yeah, so it's kind of a different beast. I'm more of a web development guy. I'm shaking the rust off of my C++ because I'm doing some training courses in C++. And I'm shaking the rust off my game development as well. I could probably sit down right now and do web development until the cows come home. But I probably will do something else in a couple of days. I don't know what I'm going to stream tomorrow. We'll see. You have to know how matrices work if you want. Well, you only need to know how matrices work if you're doing 3D game development. So to rotate in 2D, you need to know your sine and cosine. Okay? You need to know that cosine works on the x-axis and sine works on the y-axis to get you kind of a rotation. In 3D, you need to understand matrices, but also you apply those same sine and cosine, inverse cosine, and inverse sine functions inside of matrices. So 3D is definitely a lot more. We're staying away from 3D, so no matrices here. We're just doing 2D. So we're just doing some trig. We're doing some trig. Okay, so back to our update music in our game. So I want to check to see if simple audio engine, get instance. So get instance. There's a function called is perfect, is background, and this returns a Boolean, a true or a false. So what I want to do is on every frame, I'm going to check to see if there's music playing in the background. So if there is, let's just get out of here. We can just return. But if there isn't music playing in the background, then let's go and randomly fetch one of those music tracks. So let's create a string and we'll just call it whatever, tune. We know it's in the folder music and we know its theme, but then it has a random number between 1 and 14. Now we created an inline function the other day called rand_i, which is a random number between a minimum value, which is 1, and a maximum value, which is 14, to get us a random track number. So we're building out the name for the track we're going to randomly play. So 1 to 14. And then finally on this string, we need to add the extension, which is .mp3. Cool. So now we've got a random music file. We just need to use our method that we created inside of core, which we called play set background music. So let's go back and call that. So inside of core, shared core, and from shared core, set background. Brilliant. We're not going to loop though. Let's go tune, and our bool should default. I should actually put the default in the header, but I didn't. Let's just say false. So it's not going to loop. So if I put a breakpoint on here and we run this game now, we should have the theme. We should have the theme playing on our game menu screen. And then when we actually play the game, it's going to stop that theme, because we called stop any background music when we call our init, which is the first function we get into when the game is loaded, when the game starts running. And then on every frame, if there's no background music, we're going to randomly load and play an MP3 file up. So I'm going to put a breakpoint here because we can see that this logic actually triggers when a music file ends. So I'll run this. Let's see if we're getting some sound. Tile map, which is huge. Vertex array object. Better use matrices to rotate and move it. I think Cocos2d-x has some tile map magic built in. And there's a tile map. Where's that tile map thing in Cocos? There's actually an application you can use to create your tile maps for you, and it comes with a plist. All you need is the plist, which is your XML file, to tell you the individual tiles. It depends on, I guess, what you're using your tile map for, but Cocos2d tile map creator. I don't remember. Your tile map editor. There's excuse me. Here is a tile map editor called Tiled, and I've actually used this once in the past. I didn't get far with it, but yeah, the .tmx extension is for the tile map, and you just add little sprites onto the tile map, and then underneath it generates an XML file to say what each area is for that sprite. Or you could have a huge big background image and just overlay grids on it to have your tile map. And you can kind of define the width of your tile map and the size of each one of the tiles. But you can get an idea. If you're interested in tile maps, there's tons of examples. There's so many games use tile maps, and Cocos2d is probably the king of creating games with tile maps. Okay, so music theme. We clicked on play game, and now we are in our update music. Since no music is playing, we're going to randomly get one. And the tune is music theme 14, and it should play. So we can hear music theme 14 playing. We'll play for a bit until it swaps out. So obviously we need to add the sound effects too. Sound effects will allow us to hear these explosions when we hit the bad guys. So hopefully this music file will end soon. How long this guy is, but okay, perfect. So on one of the frames, we check to see if background music is playing, and it isn't. So that MP3 file we originally loaded has played. We set looping to false, so it just plays one time, and then we come back into here and we randomly get a new tune. So we're going to play theme 1 this time. So we should hear some different sound. Doesn't sound much different, but it is a different MP3 file. So we've got our random music for our background playing. Cool. So now let's add some sound effects. And we can probably just do that inside of where we handled collisions. So on every frame, we check to see if a collision occurs. If we do have a collision, then we blow up the bad guy. Now, if the bad guy is of the same color, it should be a good explosion sound. If we get hurt because he's a different color, we should have the bad explosion sound. So we can simply add, we can just go ahead and say, we could just, you know what we'll do? We'll do this. We'll define our sound enum type. We'll just name it sound, and we'll set it equal to sound of none. That way, if for some reason a sound effect isn't set in this logic here, then we'll pass none into our play effect method we created earlier. Core. Yeah, I think I've got a variable. So what did we call it? Play effect. And it takes in a sound. So we'll pass in our enumeration of sound. And we're not going to capture the sound ID that's being returned because we're not going to cancel or stop the sound effects. They're so short, it just doesn't matter. So by default, it's going to play no sound if we don't override sound, but we're going to. We're going to set sound to, this is a good sound because this is where we scored a point because the player color and the bad guy color are the same. So we can go sound explosion good. And then I'll just copy that and we will drop it in our only other location, sound bad. So this is where we took some damage. So we can hear the sound effect and they'll just play. Pretty simple. Let's run that. Hold on one sec. What are you doing, dog? Come on. My dog's just going crazy. Okay. All right, so we've got our sound theme playing in the background. Awesome. Let's check out our sound effects. So we should hear a good explosion. That sounds good. We should hear a bad explosion. And we took some damage. Bad. Cool. There we go. So sound effects, awesome. So that's working. Awesome. Well, we'll get back to the code in a sec. So let me just look here. Some chat stuff going on. So Tartarus, full stack web development. You're trying to learn it. Yeah, that's a good idea. There's definitely a lot of demand for full stack developers. Absolutely. You know, I would recommend, I guess it depends on what you're comfortable with. If you're Python, I guess Flask would be okay for a framework to use. I don't know about Ruby on Rails anymore. Not sure how powerful that is. If you're a .NET guy, you know, MVC, ASP.NET Core. Definitely Node.js if you want to be a JavaScript guy. I kind of like JavaScript. I think it's a really quick language. It's not a compiled language. It's interpreted, kind of like Python's interpreted. But it's actually pretty fast. It's pretty fast. And the paradigm's a lot different than functional programming, kind of like what we're doing here, this object-oriented functional programming. In JavaScript, there's a lot of that too, but there's a lot of asynchronous knowledge you need to have. Everything runs on a single thread. So that thread is always just executing inline statements constantly. There's no like waits really. So you have a lot of promises, and there's a cool framework called async in Node.js. But it really depends on the language and the stack that you want to go down. Do you know what it entails though? To become a full stack web developer, let's say you want to become a JavaScript full stack web developer, you're going to have to know some sort of CSS framework. And I don't mean CSS interpreter like Less or Sass. I mean like, Bootstrap or something like that. I'm full Bootstrap. And then I use Pug for templating language, so that I don't actually use any HTML. I use this kind of like this interpreted domain-specific language for your HTML. So anyway, you've got to know some front end, definitely jQuery. Back end, you're going to have to know Node.js, but on top of that, you'll need to know probably Express.js, which is kind of like what Ruby on Rails did, where it handles like posts and gets and puts and deletes on HTTP, so that you can handle different HTTP requests coming into your server. You're going to need to know most likely Ubuntu or some sort of Linux server. You'll probably have to understand how AWS works, Amazon Web Services, because most people host their servers on the cloud, on a cloud provider like Azure or Amazon Web Services, or what is that? There's the other one. I can't remember the other ones. So yeah, good luck, man. Definitely database you're going to have to pick up too, right? So JSON's better than XML. Yeah, I guess so. Handle collision for a ranged for loop. Yeah, I could do a ranged for loop for sure. Something would have to have an iterator. But yeah, I could do that. I know how ranged for loops work. Thanks. Eve Osts. Okay, if you want some space backgrounds. Okay, as for our resource files, I'll give you a little idea of where I got them. So if we go to all of our resource files, I got these images for free on, where did I get them? Where do I get all my freebie stuff? The sound I get at, it's like Free Sounds or something like that. Free Sounds. freesound.org. It's pretty cool because the search, if I go to sounds, you can actually search by tag. So the uploaders have tagged their sounds. This guy said it's kick, vox, snare, synth, blah, 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 blah. This guy's got a doorbell. So if your game needed a doorbell to ring, I mean, you could go to freesounds.org and you can look at, if you hover over this little icon underneath their name, you'll see what type of license they're providing their sound as. If it's Creative Commons Attribution license, it means it's under Creative Commons, so it's free to use. But the attribution, you have to give Androsky credit for that sound file somewhere in your game. Anyway, the sound is public domain, so you do whatever you want with it. You can modify it, you can use it as is, and you don't have to give this guy any credit. So you can understand your licenses. I made sure that the licenses for all my images and all my sounds are public domain or attribution, and I would have included an attribution somewhere. I like Free Sounds because you can search by tags, and you can actually preview the sound by, on the search results, just clicking on this little play button. So let's listen to the doorbell. I guess it doesn't sound very good, but you know, you preview these sounds, and if you like them, you can just download them and yeah, use them in your game. So that's where I got my sounds mostly. As for images, free, can't remember, free images for games. Open Game Art, I think I pulled some from there. Pexels is more of big stock images. I don't really remember exactly where I got my free images, but they're becoming more and more prevalent. Like, you get this stuff for free. Like, here's sprites, so sprite sheets, hopefully. No. Well, yeah, this guy's got a sprite sheet of 11 characters, one character. So you can see the sprite sheet. Sweet. So this guy will provide you a full walk animation, a run, a jump. That's great. And what did he build it in? So his sprite sheet is built in, don't know. Preferred tools, texture packer. Texture packer is a really popular one. I'm surprised he didn't provide the included plist. He's selling it though. You got to pay for it. Some of this stuff, I guess, is free. Some isn't. Here's freebies. Let's see what's free. So if you wanted to create a zombie game, there you go. You get some free zombie animations. So how do you do animations? So if you were given this sprite sheet in Cocos2d-x, hey, Gower Saurazus, sorry, Gower Isuz. Hello. So yeah, anyway, so let's say you downloaded this freebie. You get two male and a male and a female zombie. Awesome. 4 animation states with 10 frames in each animation. Separate PNG sequence files. Sweet. So what would we do with this? Well, let's look at what I did with our animation. So let's go back to core. And we're going off on a bit of a tangent, but since we're talking about assets for your game, the music and sound is pretty easy. You just preload it and you play it in a simple audio engine. Doing sound and music is pretty simple. Animations, a few more steps. So how did we get our animations? Well, I created one big old sprite sheet called Game Sprites. And these are all the sprites we use in the game. Because we haven't taken this game to the full extent of what it was on my old machine, I had different types of enemies, different power-ups. We're not doing any of that just for time's sake. But what we do is I created an animation of the explosion using these little puffs of cloud sprites. So I put them together in sequence to create the explosion. And this is the XML file or the plist file that's associated to this sprite sheet. And this sprite sheet was created using Texture Packer. Sometimes it puts a comment in here saying what I used to build the sprite sheet, but it doesn't look like it has to advertise, which is fine. Now I'm just going to do a Control F in here for explosion underscore. Perfect. So we've got one image, one sprite, 2, 3. I'm actually going to increase the font size so you can see what I'm talking about. Let's make that 16. Okay. So we've got this here is one sprite out of this sprite sheet. It's explosion 1. This is the key. It really isn't a PNG file. It's just a key to reference that sprite. Not a big deal. We'll see that in a sec. But it's saying, here's the rectangle, string size, sprite source size. So this explosion is going to be approximately starting at texture rectangle on the x-axis of this big image file. It'll be 597 pixels on the x. So let's say right here. And then it's 141. It depends on how the x-axis works in texture packer. Sorry, the y-axis. I don't know if it starts from the origin being in the top left or the bottom left. Probably bottom left. So we went across 597 to right about here. And we go up 124, let's say up to here. And then from there, we cut out a rectangle that's 53 wide by 41 high. So it would probably cut out, let's say, this little part of the PNG file, and it'll store it in memory as a texture. And specifically, though, it has a key named that, so we can reference that little texture. So if we go through this for loop, I created a collection of 12 sprites and basically chunked them together one after another to create an animation. Just like you would do with this. You would, if you wanted to create a zombie walk, it would be like this frame, then this frame, or this sprite, then this sprite, then this sprite. And then if you animate them all together like I did with explosion, then it'll represent the dude walking. So if we look at the explosion, in this collection, we just loop through and just build the name, which is that key inside of the P list. We just build the name explosion 1, explosion 2, and we fetch each individual one by calling this sprite cache get sprite by frame, right? The sprites are already loaded in memory because this line of code pushed them all into the sprite cache. And we just call them by the little unique name underneath the key that the texture packer XML file defined that sprite as. So I can push all 14 or all 12, pardon me, of those explosions together. And hey, what are you doing? We're building a game. Building a game with Cocos2d-x. So anyway, I push all of those individual explosion images onto the collection. Then we use Cocos2d-x to create an animation with that collection of frames. And we say we want the delay to be 0.05 seconds. So very quick, actually. And we'll add the suffix. So it's a float. So we're creating all of these 12 sprites to run as an animation with a little delay between each one of a very small fraction of a second. And then what we do is we push that animation onto the animation cache, which is just a big memory area to store animations. And we store it with the key explosion. This is just a key. If I Control Shift F and we search through, I want to search in the solution, find all, and let's see the find results. So we can see inside of the baddie source code, we actually called from the animation cache this functional working animation out of memory, and we're going to actually render it. So I get that animation we just created out of memory, get it back as an animation. We wrap it in an animate because this derives from action interval, which is the base class of how actions work in Cocos2d-x. So we want to create this action, which is an animate action, and we wrap it in a sequence. You don't have to, but this allows you to create multiple actions sequentially. So what it's saying is run the animation of all those 12 frames with that fraction of a second delay. Once you're done with that action, then we're going to call a function called destroy me, which is up here. And we actually destroy and remove that bad guy sprite off of the game. He no longer exists or does anything. So when we ran this game, that was how we did animations in 2D. So we can see as soon as I make a cell explode, that's the animation running, and then the callback to the destroy me to make him disappear. So there you go. You can see the explosion animation quickly occurred. So that's an animation. Another animation we can always see is the player. The player is constantly animating. So he's also an animation. So if I wanted to swap out the player with a zombie, I could go ahead and download this sprite sheet and just say, like, instead of the player being this goofy little guy, I want him to be this goofy little guy, the zombie. And we can just replace his animation sprites and he would look like a zombie. So I think you've learned enough Cocos2d-x if you've been watching for the last few days. That it's pretty simple to do. So anyway, that's kind of it. We've got the game over. We've got the game success conditions. We've got the sound effects. You know, it's a start of a game. It's all on GitHub. If you are into Cocos2d-x and you want to get started with a game, feel free to play with this. Memory management so far seems pretty good. We're holding pretty steady at 60 frames. The frame rate drops when a new bad guy is added to the screen, but that's expected because there's some OpenGL calls to render that guy onto the game. Okay, so things seem to be working so. Awesome. So let's see, when did we start streaming? We started streaming at about 10 o'clock my time. It is almost 1. So we've been pushing about almost 3 hours. I'm open to questions if anybody's got questions. I'm open to requests if anybody has requests as to what you would like to see me hack my way through. I've got no problem doing full stack web development. I've got no problem, I guess, doing some Cordova building smartphone apps from JavaScript using Cordova. I can do that. Whatever you want. C#. I'm thinking I'm going to do, I mentioned it in yesterday's stream, that I think I want to do in the next day or two, creating our own blockchain in code. So actually creating our own sort of pseudo, well, basically Bitcoin, recreating all of the code required to do a blockchain where we encrypt the chain, we encrypt the individual blocks in the chain. So I'm thinking of doing that, but we'll see. If not, I'll probably be back tomorrow streaming some beginning C++. So we're just going to work through looping and conditional statements, relational operations. Yeah, so that's kind of it. That's about it, guys. Who followed today? Let's see. Tardis96, man, thanks for the follow. Sid Harth Kasuri, Phobos Demio 777, Ningamer LTU, Katrine Valentine 22. Hey, shout out for the follows, guys. Let me just see something. You guys may have pushed me over the edge here. Awesome. I have just officially achieved my path to affiliate status. So I guess I can get a sub button. Yay. So, you know what I'm planning on doing is I'm going to do a Patreon account, and I am going to create different tiers in Patreon where I am going to have you guys hopefully become Patreons, and there'll be free levels as well. Like, you know, it's not all about the cash, but where at different levels you gain kind of like credits or tokens where you can spend those tokens on my time. So if you want to become a guy who can take his JavaScript knowledge and build an iPhone app that you can put on the App Store, or an Android app, then I will give you my time to do that based on tokens. So I'm not at that point yet. I'm just kind of twitching it out. I don't have a YouTube channel yet. I don't have a Patreon account yet. All I've got is this 2 or 3 week old Twitch stream. So yeah, so I'm kind of excited. I hope you guys follow. As I get more training courses done, before I put them on Udemy, I'm going to share them to all my followers as well. So like learning C++ game programming is probably a third of the way done. And it'll be game programming from scratch, where somebody asked the question about why am I using a game framework? Well, yeah, I get it. But in this game programming course, we actually do extremely low level stuff. No real frameworks involved. So yeah, I kind of want to get that done. Anyway, I'm playing it by ear. So that's kind of it for me, guys. I see there is no questions on chat. So make sure you guys follow, because then you get an email when I go live. And I'm constantly updating my stream information, so what I'm streaming for that day. And my homepage will eventually share out my Google Calendar for what I'm going to stream in the next upcoming weeks. So if I'm streaming C++, if I'm doing some games from scratch, if I'm doing blockchain, if I'm doing some full stack stuff, whatever it might be, even working for clients, whatever. So I'll have that. Make sure you follow, guys. I'm out.